In this video, I will talk about design patterns for database access code and data access objects. So what's a good design for a database-driven application? If we have no principles, we could just hack together an application that combines SQL code and Java code in an ad hoc mess. But is this a good idea? On a small application, it's probably not going to do much harm. But in larger applications, it isn't a great design. Instead, if we put all of our database code in one place, it becomes easier to maintain, easier to spot and fix problems, easier to port to different database systems. And if you have a professional database administrator, it can be easier for him or her to deal with the SQL separately. So how could we do that? Well, one approach is to just use stored procedures. We can move the SQL into the database and then just call the SQL as stored procedures with JDBC. This is fine. In fact, in terms of benefits, it's probably going to get you great performance, it may be more secure, and it may mean that you can enforce consistent security policies throughout an entire application and throughout an entire organization. A downside is that databases have different languages for stored procedures. So the more code you have in stored procedures, the harder it becomes to switch databases, say from Oracle to Microsoft. Also, by having two separate code bases, your application project and then the SQL stored procedure code stored in and running in the database, it can be harder to manage the two. Whether to use stored procedures or not is a very old debate. Database administrators prefer stored procedures, and this is often a great way to handle database code. Personally, however, I prefer to keep the SQL inside the application. So if I'm not using stored procedures, what other ways are there to improve the design and layering of our application? One solution is to use data access objects and data transfer objects. Here's the main idea. We take our application and split off the database code from the main logic of our application. Then, the database code gets split up into two parts. The data access object is responsible only for reading and writing rows from the database. And the data transfer object is used to store data from the rows. So a transfer object essentially represents a row in the database. Then when the main logic of your application queries the data access object, the data access object just returns a transfer object. When your application updates or inserts data in the database, it does this by sending transfer objects back to the data access object. So here's an example of what it might look like in code. A data access object just has a simple methods define, update, create, delete, and so on. These methods are passed or return data transfer objects. The data transfer objects are implemented as very simple Java objects that just have getters and setters corresponding to the columns of a table. So in this example, the user table in the database would just have an ID column and a name column. Here's that same pattern as a sequence diagram. Let's say you want to find a user. You first create a data access object, and then you call a method on that data access object to find a user. The data access object contacts the database. If there's a result, it creates a data transfer object. It calls the getters and setters on that data transfer object to save the data, and then returns that data transfer object to you. Now you can view the details of that user just by calling the getters of the data transfer object. If you now want to insert a new user into the database, you would create a data transfer object and set its details using the setters. You then pass it to the data access object that you created earlier, and the data access object would retrieve all the data from the data transfer object by calling the getters, and then use JDBC to store that data into the database. So the data transfer object is basically just a dumb container that's used to get data into and out of the data access object. Now, data access objects aren't the only approach. I strongly recommend reading Martin Fowler's book, Patterns of Enterprise Application Architecture, for many other great ideas. So here are some of the others. With a table data gateway, you might bypass the data transfer objects completely and just return raw result sets. This is probably a bit less elegant, but on a small and simple application, it could be a nice compromise between clean separation and simplicity. Active records are like advanced data transfer objects that incorporate the data access object functionality. They can save themselves directly to the database without needing to use a separate data access objects. I'll talk about object relational mapping later in the subject. Object relational mapping is a very powerful technique for automatically creating objects from a database. Imagine automatically generated data access objects and smarter data transfer objects that can automatically detect and save any changes you make. So in summary, if you want to improve the design of code that accesses your database, you should try to separate that database access code out from the rest of your logic in your application. Data access objects are one way to do this. And I recommend it for now as a great way to master JDBC while also learning the principles of creating well-designed applications. If you master this now, then you'll find you have a much better understanding of object relational mapping when we come to it later.